Hey guys, it's Callie. I wanted to record a quick demonstration on how to prove big theta, big O and big omega. If you look through the textbook, there's a lot of different ways to do it, and some are more intuitive than others, but I worry that our grading might lean towards a more rigorous solution. So I wanted to demonstrate that for you guys. So this won't use any theorems, it's just going to use raw algebra inequalities. So I have this problem up here. Prove f of x is 12x cubed minus 2x squared plus 3x minus 5, and that is theta of x cubed. So first of all, if we're proving theta, that means we're proving big O and big omega. So, we'll have two parts to this proof. F is O of x cubed, and F is omega of x cubed. I'll also say if a question only asks for O or omega, but it has the words optimal in it, optimal or tightest bound, anything like that, you're going to be doing both of these. Just anything optimal or tightest is really saying theta. So make sure that you have O and omega. And remember what this means is that F is less than x cubed in our extreme, and this means F is greater than x cubed in our extreme, or really, cx cubed. So the way we'll do this, I'm going to do O first. Since we have F is less than some x cubed, if we make F bigger, if we prove that F plus 5 is less than x cubed, then surely F is still less than x cubed. So in this direction, we're able to make F as big as we would like. So we could start out by just writing 12x cubed minus 2x squared, 2x squared plus 3x minus 5. And I'm going to make this bigger, trying to get it to look like cx cubed, something times x cubed. So to make it bigger, I could easily just replace this 3x with a 3x cubed. X cubed is bigger than x, so forth. So I could say this is less than or equal to 12x cubed. And I'm just going to replace all of these positive x terms with x cubed. And in this case, there's only one of them. So still 2x squared plus 3x cubed minus 5. Now, we did make an additional assumption here when I did this step. I said that x is always less than x cubed, but that's not necessarily true because, if we look at the graph of x cubed, it looks kind of like that. And so there's this spot where x cubed is actually less than x. But as long as x is greater than the intersection point, which in this case is 1, then this works. So we can make this inequality if we assume x is greater than 1. And this is where your k comes from in your proofs. So you could write this step if x is greater than k is equal to 1. So now we have this proof. It looks a little more, we can combine these like terms. We still have an x squared and a minus 5. But since these are negatives, we can just cancel them out, right? If 12x, we could just write 12x cubed plus 3x cubed, because adding 2x squared or adding 5 is only going to ever make our function bigger. So we can just write this is greater than or equal to 12x cubed plus 3x cubed, which is equal to 15x cubed. So f is less than or equal to 15x cubed when x is greater than k equal 1. And then you could write f is O of x cubed. And I would write this specific point just for grader's sake. I know some of them get really stingent about identifying your c and k. F is O of x cubed with c equals 15, k equal 1 as witness. So that's the first half done. Now to prove omega, we're going to do the same thing, but with the inequality flipped. We're showing that f is greater than x cubed. So in the same way that we were able to make f bigger in this, we're just going to make f smaller. If f minus 5 is greater than x cubed, then surely f is greater than x cubed. So we'll just rewrite this again. 12x cubed minus 2x squared plus 3x minus 5. So I'm going to make this smaller. And this is the same logic as before. So this 3x I can just cancel out. So this is certainly greater than or equal to 12x cubed minus 2x squared minus 5. I guess this also does assume that x itself is greater than 0. Because, if x was negative, then 3x could be a negative value. But we are also going to replace the x's with x cubed, so we'll eventually assume x is greater than 1. But it's okay if you forget a step like that, as long as you identify your k. But you can then, similar to before, any of these negative terms, 12x cubed, we can replace the x with another x cubed, 2x cubed minus 5x cubed, which is equal to, what is that? 12 minus 7 is 5x cubed. So we did this big string of f being greater than or equal to something. So f is greater than or equal to 5x cubed. I should write here when x is greater than or equal to 1. So f is O of x cubed with c equals 5, k equals 1 as one is. And so you have two c's and k's when proving theta. You don't need a separate c and k for theta. The definition of theta is both of these being true. So you need two sets of c and k's. You could just write, therefore, f is theta x cubed. All right. So yeah, this is it. The algebra shouldn't be too tricky on the exam. We shouldn't have any crazy things there. There's a lot of different theorems in textbook. Like, they give you a theorem that if you have any polynomial in this form, you could just pick out that term. So while that's very good to have in your mind, unfortunately, we don't accept that as like valid logic on the exam. You'll have to do this raw algebra. So thanks for watching, guys. Good luck tonight. Hope you all do well.